This is Rajesh Argiddi from WIT Solapur. Okay, so today I am going to focus on the bit called the rules of probability. Okay, this probability is required for analysis of data. So, as I explained in the previous slide also, whatever we require some tools, okay, from Python and as well as from the mathematical. Okay, mathematical tools are we require to analyze the data. In data science, we require linear algebra, then statistics we require, and the probability. Okay, so out of that, we'll focus on some of the rules of probability. What are those rules? Okay, so we'll try to focus on that particular rules. Okay, even when we have the probability, it is measure which assigns a real value of every outcome of random phenomena. When we assign this probability, it has to follow certain rules. Okay, the first condition, or before that, at the end of this session, okay, student will be able to comprehend the rules of probability. He will going to understand what are the various rules, what rules he has to follow. Okay, everything he will be understanding. When we assign, it has to follow certain rules. Okay, the first condition is that the probability we assign to any event should be bounded between 0 and 1. Okay, between this 0 and 1. See, the probability of event A should be greater than 0 but less than 1. Okay, so probability are non-negative and less than 1 for any event A. So it should be between 0 to 1. Okay, for any event, okay, we might consider also the probability of the entire sample space should be equal to 1, which means that this one of which one of the outcomes should occur. Means that there is only one outcome. Then in that case, we say that the probability of that particular event is equal to 1. And the third case, okay, in the third case, okay, it should satisfy this condition that if we are going to consider two exclusive events, okay, say whether one or the other occurs, one after the other occurs, okay, the probability that either A or B occurs is the sum of probability A and the sum of probability B if A and B are exclusive events. So these are the these are the three rules, okay, that we should follow, okay, while studying the probability or while solving the problems of probability. Okay, when we assign a probability, that easiest way of interpreting probability as a frequency. Okay, for example, okay, say we conduct an experiment. Okay, we want to say do the coin toss experiment. Let us say 10,000 times. Okay, and then count the number of times a particular outcome is observed. For example, okay, means that one coin is taken, it is tossed for 10,000 times and count those. Okay, out of that, count a particular outcome. Now let us say we are counting the number of times heads occur. Means whenever we toss, how many times head is occurring. Okay, count those head occurring. Okay, the number of times from that 10,000 counts. Okay, now suppose let us say let us denote that particular counting the number of times head occurring. Head occurring is say denoted by n of A. Okay, n of A, and A is that entire count, 10,000. So the corresponding to the head occurs, then the probability of head occurring can be defined as n of A by n, n of A divided by n. So this is bounded between 0 and 1. Okay, this is bounded between 0 and 1. And if we look at the other outcomes, okay, it will be n minus na by n and therefore it will add up the probability of the sample space, which is equal to 1. Let us go to the next slide. Okay, now let us see some of these events. Okay, one is a exclusive event and the second one is a independent event. Okay, now in the previous slide I explained that toss a coin 10,000 times. If suppose tossing a coin say 100,000 times, okay, we may get a slightly different probability. Okay, we may get a different probability. Okay. Well, let us focus on this particular slide. That is, what is independent event and what is exclusive event. Okay, looking at this particular slide, okay. We can go what is called the independent set of events. Two events are said to be independent if the occurrence of one has no influence on the occurrence of other. Okay, that is, even if the first event occurs, we will not be able to make any improvement about the predictability of B. If A and B are independent formally, probability, it is the way we consider two events to be independent is if A intersection B, and if you take the probability of that, which means that a joint occurrence of A and B can be obtained by multiplying the respective probabilities, that is probability A into probability B. If you want to find out the intersection of A and B, okay, intersection of AB and the probability of that is nothing but the productivity of the probability A and probability of B. Okay. A joint occurrence of A and B, okay, can be obtained by multiplying their respective probabilities of A and B. Let us illustrate this by an example of, again take a coin toss experiment. Suppose we toss the coin twice. Okay, now now tell me that the first toss, okay, tell me the first toss is head. Then does it allow you to improve the prediction of head or tail in the second toss? Clearly, okay, we will say that well, does not matter whether the first toss, whether it is head or tail, the probability of head occurring as the second toss is still 50%, okay, or 0.5. That means information that whatever we is provided to us, okay, the first toss has not changed the predictability of the head or tail in the second toss. Okay, so if we look at the joint probability of two successive heads, which is the head in the first toss and the head in the second toss, because we consider them as independent events, we can obtain the probability of these two successive heads as a probability in the first toss and heads in the first toss multiplied by the probability of heads in the second toss, which is nothing but 0.5 into 0.5, that is equal to 0.25. That is equal to 0.25. Okay, that is equal to 0.25. That is getting a head which is equal to head in the first times into head in the second toss. Okay, that is 50% for head in the first time and head in the second time 50%. That comes out to be 0.25% for a two coin toss. So all the four outcomes in the case of two coin toss experiments will have a probability of 0.25%, whether we have two successive heads or two successive tails, or head or tail in the heads, all will be 0.25, and this way we actually assign the probabilities for the two coin toss experiment from the probability assignment of a single coin toss experiment. Okay, this is all about the independent events. Now let us see what is exclusive event. Okay, mutually exclusive event. Okay, mutually exclusive event. Now these are events, okay, that include each other. Okay, which means that if we say that event A has occurred and that implies B has occurred, okay, then A and B called mutually exclusive events, one after the other occurrence of one excludes the other. Okay, so let us look at the coin toss experiment again. Two coin tosses in the succession. We can look at the event of two successive heads as a occurrence of head followed by the tail, and two successive heads have occurred. It is clear that event of head followed by the tail has not occurred. Okay, so these are mutually exclusive events. The probability of either receiving two successive heads or head and followed by the tail can be obtained in this case by simply adding the respective probabilities, because they are mutually exclusive events. So we can probably either say that head head or head tail, which is nothing but event of head in the first toss, which simply 0.25 plus 0.25, that comes out to be 0.50. Okay, that is 0.25 plus 0.20 is equal to 0.50, which is obtained by the basis of basic laws of probability of mutually exclusive events. Now some rules of probability. Okay, look at the next slide. Okay, following important probabilities. Okay, rules that can be proved using Venn diagram. S is equal to so the probably outcomes are getting head and head tail, and complement of this will be automatically tail head and tail. Okay, so if a complement of A is nothing, can be obtained, probability of complement of A can be obtained, the probability of the entire event minus the probability of A. Okay, that is 1 minus probability of A, that is this is 1 or 0.5, that comes out to be 0.5. Okay, that comes out to be 0.5. Now look at this particular question. If two events A and B are mutually exclusive, okay, what is the output? Okay, whether it is A, B, or C, or D. Okay, the possible outcome. Take a pause over here. Think and write the answer. Now check your answer over here. The correct answer are option B and option C. Okay, addition of probability A plus addition of B and 1. Okay, so these are the different references, and I hope you have understood. Thank you very much.